All right, we're going to do a slightly more complicated example now. We're going to set up bounds of integration for the so the solid D in the first octant bounded by the cylinder x squared plus y squared equals 4 and the plane 2y plus z equals 4. And this is a lot of words, so what's going to help us first is to draw a picture. If you haven't heard octant before, just like we had quadrant for the 4 parts of the XY plane, we have octants for the 8 parts of the XYZ coordinates. And so first octant just means X, Y, and Z all positive. Just this sort of corner of 3 space that I tend to draw first usually. And then we're bound by a cylinder, x squared plus y squared equals 4. So that's something that has radius 2 and is centered around the origin and would go on forever, but I cut off my picture right here. So there's my radius 2, there's my radius 2. And we actually don't care about what's below the x-axis or to the inside the screen of the y-axis because we only care about this region out here where x, y, and z are all positive. And then we're bounded by this plane. That's not a good plan here. It's a little better. All right, here's the plane 2y plus z equals 4. Right there. And that was my cylinder, x squared plus y squared equals 4. And so the region they're asking us to set up the bounds for is going to be kind of this corner of the cylinder up to beneath this plane. So imagine that like you have a can and a friend of yours was very like aggressive with a knife and managed to cut through the can, and we're finding the volume of that sliced diagonally can. If that helps you visualize the picture, which I know is very hard to do. All right, so first octant told us x is greater than 0, y is greater than 0, z is greater than 0. And then we also have x squared plus y squared equals 4 and 2y plus z equals 4. Those are kind of the facts that were given to us in this sentence. And we just want to set up our integral. And we get to pick whatever order for the bounds of integration we want. But no matter what order I pick, I know that x, y, and z are bounded below by 0. That was sort of one of the first things that we said, so I can go ahead and fill in those 3. And what I'm missing are the upper bounds for all 3 of them. And so I get to look at my picture and pick the order of integration I'll do. So I think I'm going to do z first. Z is going down on this picture up. And so I have a good feeling that that means going up to the plane. And then I'll do y next. For our picture, y means starting from the left and going over to the right-ish. And so to me, that looks like it's going to depend on the cylinder. And then I'll do x last. just because I wanted to. Okay, so if I want to set my bounds for z, I look at the information I have, and I find the one thing that depends on z. So I say, okay, 2y plus z equals 4. That was that plane right there, which is the same as saying z is equal to 4 minus 2y. So I start down here in the xy plane, z equals 0, and I go up everywhere to the height of this plane. Z equals 4 minus 2y. So my z is bound by 4 minus 2y above. Next up, I want to figure out my, here, I'll do like a symbol there. Found it from that part, and I tried to draw these little arrows. Next, I'm going to try to do my y. Oh, I should put a star there too. Okay, next up is my y, and so I see here is an equation that depends on y. This one, oops, this one depended on y too, but I already used it. So we can see what that means in a second. But for now, I know that this x squared plus y squared equals 4 is taking me up to the height of this circle, going from left to right. And so it's given by x squared plus y squared equals 4. That means y is equal to plus or minus square root 4 minus x squared. But the negative root is just the backside of the circle that we actually don't care about because it has negative y. So we are going to pick the positive square root here. And so the upper bound for y is the top edge of that circle. Y equals square root 4 minus x squared. If I use this 4 equals 2y minus z equation, it actually comes from setting 4 minus 2y equal to 0. Gives me y equals 2. So when the z bounds meet each other, I go up to a maximum height of y equal to 2. But since we choose to define y in terms of the function of the circle height that also defines the surface, we don't use that. So if somebody had just told you to find the intersection of the plane with the xy plane, then we would have had to use this equation again. But because we have that other bit of information, we don't. Okay, purple. Okay, so X is sort of from the back to front of the picture, I guess. And so we did have that it starts at x equals 0, the y-axis, and then it goes out to this edge of the circle, basically, but we already defined the circle in terms of y, so we really just care about the furthest out that we can come. And so that actually comes from here. I'll do it like a dashed line. If we care about when the upper bound for y touches the lower bound for y, we've got 0 equals 4 minus x squared, or 0 equals 4 minus x squared. Undo the square root. X equals plus or minus 2. And again, x is bounded below by 0, so we don't care about the minus 1. So it is that we use the x equals 2. So our upper bound for x, the furthest out it comes, is up to 2. And that's how we would set up the bounds of integration for this problem.